Hello students, myself Professor Ankur. I welcome everyone for the GATE theory session on analog circuits. Today we are going to discuss an important topic, op-amp as a comparator. This is our 8th session on operational amplifier. Let's start with the session now. So before we actually start with the session, we will just like to revise regarding the property of op-amp. Operational amplifier is basically an amplifier which is having two inputs, V plus and V minus, normally notified as V1 and V2, where you will find the V1 pin as the non-inverting pin and the V2 pin as the inverting pin. The input resistance of the op-amp Rin is going to be very, very high. And when we talk about the output VO, the value of VO is defined as AV into V1 minus V2, where you can see the value of current source along with a resistance R out in series with that. That is the output resistance of the op-amp. So this is basically defined as an equivalent circuit of the op-amp. So the output of the op-amp is going to be VO into AV. VO is equal to AV into V1 minus V2, where V1 is the non-inverting input and V2 is the inverting input. So the simple understanding is that the op-amp can work like a comparator under open loop configuration, where if V1 is greater than V2, the output is going to be positive and the output is justified as positive VSAT or plus VSAT. And if the V1 pin is less than the V2 pin, implies the output is going to be negative, which will be defined as minus of VSAT. So hence, under open loop configuration or arrangement, the operational amplifier will work like a comparator, and hence it is called as an open loop comparator, which will either generate plus VSAT or minus VSAT depending on the status of the input, whoever is bigger. Now let's have a look at op-amp as an inverting comparator, where you can see the input is given to the minus pin and the plus pin is having a reference voltage. So now whenever we talk about a sinusoidal input being given, you can see a sine wave which is represented in the form of a blue color. And if you find the value of Vi, which is going to be greater than the reference voltage, automatically the output for that point will be minus of VSAT. For all the other situation, the output is going to be plus VSAT. The transfer characteristics, which is a relation between Vout and Vi, is basically shown on the right hand side figure, where we can clearly justify that as soon as the input value crosses the value of the reference voltage, the output will switch from plus VSAT to minus VSAT. So this is the way the op-amp is going to work like a comparator. Since the input is given to the inverted pin of the op-amp, the configuration is called as inverting comparator. Now, if you observe carefully, this comparator is normally called as the non-inverting comparator, because here the reference is connected to the inverting pin and the input is given to the plus pin. So the very simple logic here is, if you can see the VCC battery and the two resistances of equal value, the reference voltage will be exactly half the value of the supply voltage. And that's the reason in the diagram you can see the reference is indicated as VCC by 2. So whenever the input crosses the reference or the input is bigger than the reference, you will find the output is going to be plus VSAT. And whenever the input is less than the reference, the output is going to be minus VSAT. So this is the way in which the op-amp can be used as a non-inverting comparator. Now this is the basic logic of comparator, where the op-amp is working under open loop configuration. But all of us are aware that due to the impact of noises, there can be glitches at the output or fluctuations in the output, or you can say a false voltage can also be generated at the output due to impact of noise. So to avoid such situation, we landed up with a concept called as closed loop comparator, which was under the topic of Schmidt trigger. So whenever we talk about Schmidt trigger circuits, they are normally operating as closed loop comparator. So this is all about the operational amplifier as open loop comparator. Thank you.